Okay, we are on number 12. A simple random sample of size n equals 200, so that's our sample size, is obtained from a population whose size is big N equals 25,000 and whose population proportion with a specified characteristic is P is 0.65, so that's the population proportion. Describe the sampling distribution of P. So we want to know, is it normal? So is it normal? So that's the first thing we're going to ask ourselves. And because it's talking about P, the two things we're going to ask ourselves are, is N less than or equal to 0.05 big N? And is NP 1 minus P greater than or equal to 10? So those are the two things we want to know about. So for the first one, what is little n? 200. Is that less than or equal to 0.05 times what? 25,000. So I'm going to go to my calculator. And all we're doing on this first step is saying, is the shape of our distribution going to be normal or not? 25,000. So, is 200 less than or equal to 1250? Yes or no? Yes. So for my next one, my N is going to be 200. What is my P? 0.65, so what is my 1 minus P going to be? 65% plus what? 35%? Or you could have done 1 minus 0.65. We want to know, is that greater than or equal to 10? So I'm going to clean up the front part. So it's going to be 200 times 0.65 times 0.35. So is 45.5 greater than or equal to 10? Yes. So because both of those are true, that is telling me that my p-hat, or my sample proportion, is approximately normal. So we are going to have a normal distribution. So that's all that first thing's going to tell me. Now, because we're normal, then we need to know what is my mean and what is my standard deviation. What is my mean going to be? 0.65. My mean is going to be that P, because there's no other things in the problem that it's going to tell me. I'm asking 200 people in my sample. I'm asking 25,000 people in my population. So the only real data is 65%. So that's going to be my mean. How am I going to get my standard deviation? The square root of P, 1 minus P over N. So what was P? 0.65. What was 1 minus P? 0.35. And what was my N? 200. 200. So in my calculator, I am going to do the square root of 0.65 times 0.35 divided by 200. And I did the square root of the whole thing. So that tells me what my standard deviation is going to be. I think I pulled it over. There we go. So we just figured out from part A that because these two things are correct, we have a normal distribution, and our mean is 0.65, and our standard deviation is 0.0337. So we can draw it. We have a normal distribution with a mean of 0.65 and a standard deviation of 0.0337. We good? Now, if I come down a little bit, that just shows you the cute worked out version. Yes, yes, it's approximately normal, so this is my mean and this is my standard deviation. So part B, what is the probability So what are we trying to do now? Find the shade. So what kind of problem am I going to do? Normal CDF. Okay? So, from the previous problem, we just realized that it's a normal CDF. My mean is 0.65. My standard deviation is 0.034. We just got that from the previous problem. What is the probability of obtaining X equals 136 or more individuals with the characteristic? That is, what is P hat greater than or equal to 0.68? Okay? Now, when you're doing this type of problem, you must have percentages on the bottom. So, like when we were doing relative frequency, I told you, either you had data here or you had percentages here. For these, because this is a percentage, all of these need to be percentages. Now, it gave me this number and then it gave me this number. And you're like, how do I know what to use? How many people did I ask in my sample? 200. So what they did is they said 136 people out of 200. So if I go to my calculator and I turn 136 out of 200 and I turn that into a percentage, that's where they're getting the 68 from. They turn like a data point into a percentage so that we can put it down here. Because you can't just have a data point. You just can't have a number. It's got to be a percentage. So they did 136 over 200 people to turn it into 68%. Does that make sense? So 68% is what we're going to put down here, but it's really this over the total number of people that we asked. So this is kind of like, quote unquote, my z-score. 0.68, and we are shading which way? Or more, so we're shading this way. Now, we're still going to do the normal CDF like we've always been doing. Normal CDF, where did we shade begin? 0.68, where did we shade end? 9999. What is my mean? 0.65, and what is my standard deviation? 0.034 or whatever. And I usually take it out more. And the good news is, y'all, your next test and your final exam are all multiple choice. So if you don't take it out enough places, it'll be pretty close. So when I go to my calculator and I type it in, this is what my normal CDF is going to be. So that means that 18% or 18.7% of that curve is shaded. Okay? Now this one says, what is the probability of obtaining X equal 118 or fewer? So we still have our mean from part A is 0.65 and our standard deviation is 0.034. So 0.65 and 0.034. Now, that's not a percentage, so they did 118 over 200. So if I come over here, it's going to be 118 over 200. That's where the 0.59 is coming from. Those are really two of the same things. One's just as a quote-unquote data point, and one is as a percentage. So we are doing 59% or fewer. It says what is the probability, which means we're doing the shade. So it's going to be normal CDF. We're going to start at negative 9999. We're going to go to 0.59. Our mean is 0.65 and our standard deviation is 0.034. Does So negative 9999 to 0.59. Our mean is 0.65 and our standard deviation is 0.034. And then if I come down, that will show you that your part that's shaded is 3.76% when you plug it into the calculator. And then here, they just chose to do the square root of that times that divided by that wrapped up. Yes?
That's not what my.
Okay. Let's look. Did you just type in 0.034? Okay, that may be why it's a little bit off. Second var's normal CDF, negative 99999, comma, 0.59, comma, 0.65, comma. I'm going to do it both ways. Square root of 65 times 0.35 divided by 200, close it. Okay, that's if I use,
0.65.
0.59. Okay,
You did the square root of 65.
oh, that makes a whole lot of difference, doesn't it? Thank you. Yeah, I think you got rid of it. Second bars. Normal C. Negative 999, comma, 0.59, comma, 0.65. Oh. Square root 65 times 0.35 divided by
You did
2.65.
65 again.
Oh! Second, insert, decimal. There we go. Close it. Oh, okay, that's if I do the whole thing. And then if I go back and do second enter, and then I take out and just do the rounded. And I think this is what Nautica was doing the rounded, and it gave her a little bit different. So if I take out all this ending part and do the 0.034, which is why I don't like doing the rounded. So the only difference is here I did all of it typed in, where here I did the rounded. You can see how your answers, the 0.03 are the same, but this is 76 and this is 88. The answers are going to be multiple choice, and they're going to go, I think all answers are to 4 decimal places. So I prefer to do the whole thing or take it out more decimal places than the 4, or than the 3. I usually take it out 5 or 6. Cool? All right. I'm going to let you try this one. Describe the sampling. Tell me if it's normal, and if it is normal, give me the mean and the standard deviation. first thing we want to do is to know, is it approximately normal? Do we know little n? What is little n? 500. Do we know big N? We don't know big N. Now, this one says to go ahead and say, yes, this is true, since we don't know big N. On the test, I'm going to tell you little n and big N. I'm not going to give you one like this. So on the test, you're going to know little n and big N. But for this one, they say go ahead and say yeah. I don't know why they say go ahead. But they say go ahead and go say yeah, even though we don't know what big N is.
Well,
Now, let's
big
go
N
ahead and do
is-
this one. What is little n?
Isn't Big N like 300 million? Since it's adult Americans?
Yeah. Because if we're doing all adult Americans, it's going to be the population of the United States of Americans.
Yeah.
But that's going to include the children and the Americans. But we know it's going to be a big number.
Yeah, but it's gonna be, if you take 5% of that, it's still gonna be
Huge.
in the realm of 15 million.
Yeah, it's going to be huge.
And 500 is gonna be a lot.
All right, for the next one, what is N? 500, what is P? 0.39, so what is 1 minus P? 0.61. We want to know, is that answer greater than or equal to 10? So I'm going to do 500 times 0.39 times 0.61. Is 118.95 greater than or equal to 10? Yes. So both of those are correct, so we're going to say P hat is approximately normal. So that was the first part. So because it's approximately normal, we need to know what is the mean and what is the standard deviation. So what is our mean going to be? 0.39. If I come back up here, my mean is going to be the 0.39. The 0.61 was our not. So the mean is going to be 0.39. How do we get our standard deviation? P, 1 minus P over N. So my standard deviation is going to be 0.39 times 0.61 divided by 500. So my standard deviation is going to be the square root of 0.39 times 0.61 divided by 500. There's my standard deviation. So we've got to remember what we just did in case we need it in part B. We just figured out that we have a normal distribution with a mean of 0.39 and a standard deviation of 0.0218. That's what we just figured out. It says describe it. So 39% is our mean and 0.0218 is going to be our standard deviation. And it is normal because both of those are true. Yay? And then there's the pretty version. Okay, both of those are yes. My mean is 0.39. My standard deviation is the answer of that. What is the probability that in a random sample of 500 adult Americans, less than 38% believe that marriage is obsolete? So we just figured out that we have a mean of 0.39 and we have a standard deviation of 0.0218. And we want to do less than 38%. Can I put that number down here? Yes. Why can I put that number down there? Because it's a percent. Because we said we can only use percents down there on the bottom. So 38% can be used down there as 0.38. We want less than. So we're going this way. And because we're doing probability, that means we're going to do normal CDF. Where did my shade begin? Where did my shade end? My mean and my standard deviation. And if you don't want to use that, you could have typed in the square root of 0.39 times 0.61 over the square root of 500. You could have typed in that whole thing instead of the 0.0218. And that would have given you that whole answer. That's going to be your probability. All right, this time we're doing between 40% and 45%. Between 40% and 45%. We still have from part A that our mean is 0.39 and our standard deviation is 0.0218. Because we have a percentage on the bottom, we can only use percents. Good news is both of those are percentages. We are shading between 40 and 45%. Where does my shade begin? 0.40. Where does my shade end? What is my mean? Where's my standard deviation? Okay. There's going to be my answer. Whoops. This one's a little bit harder. We still know that my mean is 0.39 and my standard deviation is 0.0218. What is the problem with this one? It's not a percent. We don't have a percentage for that bottom. So how do we get a percentage as our quote-unquote data point? 210 divided by 500. So when you're doing these P's and P-hats, that bottom number's got to be a percent. So I know that this is 0.39. I know this is 0.0218. So to get my p-hat, I'm going to do 210 over 500. Somebody with a calculator, what does that give me? 0.42. Now that that's a percentage, I am happy. So 0.42 is going to be my percentage that I can put. I can only use percents along that bottom. And it's going to be percentages or higher. So that's that number that I've got to put down there. I can't use that 210. Because it's like saying, I made a 210 on a test and everybody else is saying the average in my class, the average in my class, the average in my class, and you're using a test grade. We're using apples and oranges. So when I do, scooch up so that you can see, I did the 210 over the 500 so that I could do the percent. They wanted that or greater, so instead of doing the 210, I did the 42%. I started at 42%, I went to 9999, my mean and my standard deviation gave me 0.0845, and I want to know, is that usual or unusual? Usual, because it is greater than 0.05. Wasn't that bad? It just has different stuff. Each one has different stuff. So when you study, you're going to have to know which one do I use. So what I just did is I pulled some different types of problems to get us used to, is it just a data point, or am I going to use data over, old standard deviation over the square root of the size of the group, or am I going to use P and 1 minus P over the square root, I mean, which one am I gonna use? So for the rest of the class period, that's it for all the new stuff. So for the rest of the class period, I just kinda, and I wrote in a hurry, so they're like all over the place. Which singer helps us with the shading of the normal curve? Beyonce. To the left, to the left. Most important question. Find the z-score of a standard normal curve to its left if the area of the standard normal curve, if the area to its left is 0.16. Find the z-score. So what are we doing? Inverse norm. Okay? So I'm going to draw a picture. If it's a standard normal curve, what is my mean and my standard deviation? 0 and 1. They're telling me that the area to the left, so whatever that's going to be, that area to the left is 0.16. So because we are finding z-score, that is screaming inverse norm. So inverse norm is when we do area to the left, comma, mean, comma, standard deviation. So I'm going to do the inverse norm. What is my area to the left? 0.16. What is my mean? 0. What is my, never mind, I've already written it. So I'm going to come out here, I'm going to do second vars. Go down to inverse norm, and it is going to be 0.16, comma, 0, comma, 1. And your answers are multiple choice, so you're just going to be able to have to figure out, and they're all going to be rounded to like 4 decimal places. Cool? Number 3, why is the graph not normal? It's skewed, it's not symmetric. Okay? So for this one, it's skewed, not symmetric. Number 4, tell me what is the mean and what is the standard deviation? 70 is your mean. What is your standard deviation? 10. Is everybody cool with that? Test scores are normally distributed with a mean of 80 and a standard deviation of 5.4. If 25 people are randomly selected, find the probability that mean test scores are less than 62. Not is less, are less, my bad. Do y'all want to try it or you want me to do it? Try it, y'all, try it. I made them up, so I'm doing them with you. Ooh. I probably got cancer for that one. Anybody else probably got cancer?